right. Here are the answers to homework number 7. I'm going to scroll through them, then we'll talk about them. Okay, so these first 4 problems, we are just trying to write an equation for a line in point-slope form. We're going to use the formula y minus y1 equals the slope times x minus x1. You need to plug an ordered pair from your line into x1 and y1, and substitute the slope in for m. So in this first problem, I would have y minus the y value, which is 1, equals 3 times, well, 3 is the slope, times x minus the x value, which is 2. There's my equation in point-slope form for that line. Number 2, I'm using the same formula up here. All right, I'm going to substitute my x value in for x1 and my y value in for y1 and my slope in for m. So my equation would be y minus the y value, which is -5. So I'm going to make that a plus because minus -5 is really +5. Equals -2 times x minus the x value, which is -3, so that's really +3. Number 3, I'm going to substitute my x and y values in for the x1 and the y1. So I would get y minus the y value, which is 11, equals the slope, which is 3/4, times x minus the x value. Well, the x value is -4, so that's going to be +4. And number 4, I'm going to go ahead and substitute my x value in for x1 and my y value in for y1. So I would get y minus the y value, which is -3. So minus -3 would be +3. And that will equal the slope, which is -2/3, times x minus the x value, which is 0. So this one can probably be written better as y plus 3 equals -2/3 x, and I don't need the -0. All right, here I need to take an equation that is written in point-slope form. This equation is written in point-slope form, and I need to name the point and the slope that was used. Well, the point is these two numbers. Remember that the formula has minus in front of those. So this is -3, or -3 for the x value, and the y value is just 2. And the slope is right here, the slope is 2. And so now I can go ahead and graph that by graphing the ordered pair -3, 2, and using the slope to go up 2, right 1, up 2, right 1, or down 2, left 1. And I could draw my line. Number 6, I need to name the point that was used to write this equation. The x value is right here, and the y value is right here. Remember that typically those are minus, so that x value must be a -1, which turned it into a plus. And the y value as well must be a -3. And of course the slope is right here. The slope is -2. I graph that now by graphing the ordered pair, -1, -3. And using the slope to go down 2, right 1. That's what a slope of -2 is telling me. Down 2, right 1. Or I could go up 2, left 1, up 2, left 1, up 2, left 1, and draw my line. Number 7, I have an equation written in point-slope form. I need to figure out the point that was used. Of course, that is right here. The x value is -5, right? Normally that's a minus, but it turned into a plus because it was minus -5. Same thing over here. Normally that's a minus, so the 1 must be -1. And the slope is -3/5. I would graph that by first graphing the point that I know is on the line. That's -5, -1. I would use the slope of -3/5. The -3 tells me go down 3 and then 5 to the right. 1, 2, 3, 1, 2, 3, 4, 5. And my line would look something like that. Here I need to figure out the point that was used to write this equation in point-slope form. Well, those numbers are right here and right here. Now the fact that I have no number over here tells me that must have been a 0. This must have been 1/2 times x plus 0. So my point would be x equals 0, and then y equals the 4. And the slope, of course, is right here, which is 1/2. So I would start by graphing this line. I would start to graph this line by graphing the point, which is 0, 4. And the slope is telling me up 1, right 2, or down 1, left 2, down 1, left 2. And so my line looks something like that. All right, in each of these I need to look at a line and name the equation for it. Okay, the equation I get here in number 9 is going to depend on which point I use for the equation. First, I always need to know the slope of my line, and I can find the slope by doing the rise over the run. 1, 2, 3, 4, 5, 6. 1, 2. This line has a slope of 6/2, which equals 3. And then to write the equation, I need to pick a point. If I pick this point, my equation would be y minus the y value equals the slope times x minus the x value. Of course, if I use this point, my equation would be y minus the y value equals x times x minus the x value. Either equation is fine. They are the same equation, which if you put them into slope-intercept form, they would turn out to be the same. Number 10, first I need to figure out the slope, and so I would make my little triangle, and I would use rise over run again. In this case, did you notice that the graph is counting by 2s? It has a scale of 2s. So this is actually 1, 2, 3, 4, 5, down 5. So the rise is -5, and the run is 2, 4, 6, 8, 10. So the slope here is -5/10, which reduces to -1/2. All right, now that I know the slope, my equation I write depends on which point I use. Both points are going to give you the same equation if you changed it into slope-intercept form, right? They might look different in point-slope form, but they're actually the same, which you could see if you changed them into slope-intercept form. I'm going to go ahead and use this point. So my equation would be y minus the y value equals the slope times x minus the x value. The x value is negative, so that'd be +4. Or if I used this point, my equation would be y minus the y value equals the slope times x minus, oops, I messed that up, didn't I? Let's try that again. How about y minus the y value, which is 4, equals negative 1/2 times x minus the x value, which is the 6. There we go. All right, last up, number 11. In number 11, if I want to write an equation, the first thing I have to know is the slope. The slope would be figured out by using, of course, rise over run. In this case, the rise is 1, 2, 3, 4, 5, 6. Actually, it's negative 6 because it's going down. And the run is 1, 2, 3. So that gives me a slope of negative 2. Now, the equation I write is going to depend on which point I pick. Even though the equations might look different in point-slope form, they are actually the same equation, and you could see that if you changed them into slope-intercept form. They would both change into the same thing. I start with this point, so my equation would be y minus the y value, which is 3, equals the slope, negative 2, times x minus the x value, which is negative 4, so that'd be plus 4. Or, if I used this point to write the equation, my equation would be y minus the y value, which is negative 3, and make that a plus 3, equals the slope times x minus the x value, which is negative 1, so minus negative 1 would be plus 1. All right. All right, for each of these, I'm supposed to take 2 points and write an equation in point-slope form. Okay, so for number 12, the equation you get in point-slope form is going to depend on whether you use the first point to write your equation or you use the second point to write your equation. But either way, when you change it into slope-intercept form, it should be the same equation. All right, the first thing you need to do is you need to figure out the slope. The slope would equal y minus y, that'd be 3 minus negative 2, over x minus x, that'd be 5 minus negative 3, and that gives you a slope of 5/8. I'm going to go ahead and write this equation using the first point. So my equation would be y minus the y value equals the slope times x minus the x value, but it's minus negative 3, which is really plus 3. There's my equation in point-slope form. Your equation could have used the second point here, and that would be fine. And when we go ahead and change it into slope-intercept form, they're going to be the same. So to change it into slope-intercept form, I need to get the y by itself. First, I'm going to distribute the 5/8 over here. Then I will subtract 2 from both sides. So first, I end up with 5/8 times x, that'd be 5/8x, plus 5/8 times 3, that would be 15/8. And then I would want to subtract 2 from both sides. And that would give me y equals 5/8x, and I have 15/8 minus 2. Well, 2 is actually equal to 16/8. So 15/8 minus 16/8 would be negative 1/8. And my equation is in slope-intercept form. Number 13. All right, in number 13, the equation I write for point-slope form is going to depend on whether I use the first point to write the equation or whether I use the second point to write the equation. But either way, after you write it in point-slope form using one of the points, when you change it into slope-intercept form, you should get the same equation either way. Let's see what happens. First, I need to calculate the slope to write the equation. And the slope would be the y value minus the y value over the x value minus the other x value. That gives me a slope of 3/8. I can then use my slope, and I'm going to use the first point to write my equation. So my equation would be y minus the y value equals 3/8 times x minus the x value, which is -5, so it's going to be minus -5 or plus 5. That's my equation in point-slope form. Again, your equation might be different if you use this point. It'd be y minus 4 equals 3/8 times x minus 3. But as we change it into slope-intercept form, they will turn out to be the same. To change this into slope-intercept form, I need to get the y by itself. And to get the y by itself, I'm going to distribute the 3/8 to the parentheses, and then I'm going to add 1 to both sides. So first, I would get 3/8 times x, which is 3/8x, plus 3/8 times 5, which is 15/8. And then I would add 1 to both sides. And when I add 1 to both sides, I get y equals 3/8x. Now, 15/8 plus 1 would be, 1 is actually equal to 8/8. So 15/8 plus 8/8 gives me 23/8. And there's my equation in slope-intercept form. Number 14, I simply need to write an equation that has a slope of 3/5. That's all that matters, is the slope is 3/5. So I can make, in point-slope form, I can make the point whatever I want. I might go y minus 1 equals 3/5 times x minus 1, just to make things easy. But this number and this number could be any number you want it to be. In slope-intercept form, I can make the y-intercept anything I want it to be. So maybe I would just say y equals 3/5 x minus 1. Again, this number could be any number you want it to be, since it was not asked of you to be any particular number. All right, the story problems. So in this first table, let's see. I am supposed to model the data in each table with a linear equation in point-slope form. Let's do that first. So in number 15, if I'm going to write a linear equation in point-slope form, the first thing I need to do is figure out the slope. I will use these first two ordered pairs to figure out the slope. And that would be y minus y over x minus x. That equals -900 over -2. I mean positive 900 over -2, which would be -450. So the slope here is -450. Now I can go ahead and write my equation. And my equation would be, we'll call this part A, would be y minus, all right, I'm going to go ahead and use the first ordered pair to write my equation. 3600 equals -450 times x minus 2. All right, I put 3600 in for y, I put 2 in for x, and got my equation. Part B is saying convert each equation into slope-intercept form. So to do that, I need to get the y by itself. To get the y by itself, I would start by distributing the slope. That gives me y minus 3,600 equals negative 450x plus 900. Then I need to add the 3,600 to both sides. And that gives me y equals negative 450x plus 4,500. And the last part, it says, tell what the slope and the y-intercept represent. All right, so the y-intercept is always your initial amount. It's the starting amount. It's the amount when x equals 0. So in this case, the y-intercept is the starting distance from the airport. And that would be 4,500 miles. The slope is your rate of change, right? The slope is how much the y is changing per x. So in this case, the slope was negative 4,500. That is going to be miles per hour. So the miles from the airport per hour is going down by 450 miles. Means the airplane is getting closer to the airport by 450 miles per hour. So I'd say the slope says the distance from the airport is decreasing by 450 miles per hour. That could be written different ways, but there you go. All right, problem 16. Let's talk problem 16. So in problem 16, the first thing I need to do, it asks, is write a linear equation in point-slope form for the table. So to write my linear equation, the first thing I always need is the slope. I'm going to go ahead and take these first 2 points and use them to calculate the slope. So the slope would be the y value minus the y value over the x value minus the x value. Or in this case, that would be 12 over 2, or 6. The slope of this line is 6. Now I can write my equation, and to write the equation I'm going to need a point. I'll go ahead and just use the first point, and I will say my equation is y minus 18 equals the slope times x minus 3. All right, part B is saying convert that equation into slope-intercept form. So I would go ahead and distribute the 6. All right, to put it in slope-intercept form, I need to get the y by itself. You would get the y by itself by simplifying the right side and then adding 18 to both sides. First, this would give me 6x minus 18, and then I would need to add 18 to both sides. And that gives me y equals 6x, negative 18, plus 18 is 0. I just get y equals 6x. All right, part C is asking me, tell what the slope and the y-intercept represent. All right, so they always represent the same thing, right? The y-intercept always represents the initial amount, right? Or the amount when x is 0. In this case, x is my time washing cars. So the y-intercept is going to be how many cars I've washed in 0 hours. And the slope, well, let's do the y-intercept first. So the y-intercept would be, let's see, I have washed, let's see, the y-intercept is 0, right? There is no y number out here in slope-intercept form. That means it's 0. So I have washed 0 cars to start. Or I have washed 0 cars after 0 hours. That makes sense. The slope is the rate of change, and it's always the y units over the x units. So it's going to be cars washed per hour. And in this case, the slope was 6. So the slope means I wash 6 cars per hour. All right, there you go. Problem 17. All right, it says a sign says that 3 tickets cost $22.50 and 7 tickets cost $52.50, and I am supposed to write an equation in point-slope form that represents the cost of the tickets. All right, so one of the things that's been given in this problem is they gave you 2 data points, right? They gave you 2 ordered pairs. You could almost make a little table where x is the number of tickets and y is the cost. And they gave you 2 of these points. They said 3 tickets cost $22.50 and 7 tickets cost $52.50. You know, you'd think maybe you could just divide $22.50 by 3 and you'd see how much each ticket cost. But that doesn't always work because sometimes there's maybe tax. Well, tax isn't a great example. Sometimes there's a service charge if you order them online or through a box office. So we're going to go ahead and use these 2 points to write our equation. And as always, the first thing you need to do when you write an equation is calculate the slope. So the slope for the situation would be y minus y over x minus x. In this case, that gives me 30 over 4, or 7.5. The slope of this line is 7.5. So now I can go ahead and write my equation. And to write my equation, I'm going to go ahead and use the first point and the slope. And my equation would be y minus the y value equals the slope times x minus the x value. And there you go. I think that's all I'm supposed to do. One more interesting point, if you put this in slope-intercept form, you would have y equals 750x minus 2250 plus, oh, that'd be it. There was no service charge. The tickets cost $7.50 each, and the starting amount was 0, which means there was no service charge or something to start. All right, hope that helps.